All right, Professor Garb here, back with the second half of lesson 3.2, and we're on question 12 right here. So here's the question right here, and we're asked to find the domain and range of the function. Well, domain is all possible x values, so that's going to be 2 hard bracket. Okay, that's not an infinity. So that is 2 hard bracket, comma, not infinity, comma, 1 soft bracket. Now, that's domain, and the range is going to be our possible y values. If you see down here, okay, right down here, starting at 0, including 0, going up to 4, not 3, but 4. So our range is going to go from, including 0, up to 4, and it does include 4 as well. All right, next one down here says, write the domain of the function using interval notation. Okay, so the domain, which is going to be our x values down here. It's going to go from negative 3 to 5. So you're going to go from negative 3 to 5 are our possible domain values, and our range is going to go from down here at negative 1 all the way up to 1. Hard bracket, hard bracket. Next, what is the range of the function? Well, the range of that function, as you could see, is, if you have the curve here, it goes from, this is just a range, so going from 2 up to 6. So it does include 2 because of that dot, and it does include 6 because the curve indicates that it does hit there. So that's going to be hard bracket 2, comma 6, hard bracket, and that's the range. Okay. Interval notation for the domain and range. Okay, so same idea here, but I suspect this goes on forever here. It's down in the corner, so you have to be careful with that. Let's take a look. But domain is going to go, well, at least from negative 4 to 14. So it's either, well, it goes below negative 4. We can't really see it. So I'm going to say negative infinity because I can't see where that graph is going, to 14, including 14. So it's either that, I mean, we can't see how far below negative 4 it goes, but it does go below negative 4. So I would be led to believe that would be our domain. And the range would be, because it looks like negative infinity down here all the way up to 6. So I'd say that goes from negative infinity up to 6. Hard bracket. Next, domain and range. Now we have some discontinuous functions, some functions whose graphs disappear. And we can handle that. No big deal here. We just have to write our domain and range in parts. That's the way you need to see it. So our domain is going to start in the far left here. Negative infinity approaching 3, negative 3. So you're going to have negative infinity approaching negative 3. And then negative 3 to positive infinity. So, and negative 3 to positive infinity. Not including. And the range seems like it's negative infinity. It's not limited at all. I don't believe it goes to 0. Yeah, negative infinity to positive infinity. Doesn't just anywhere on the graph. The lowest point's here. The highest point could be up here. So negative infinity, positive infinity. Keep on going. Domain and range, domain and range. Okay, so x is between. So this is the between language, the way to write intervals. And when you put the variable in the middle, we say between. So we say the domain here is between 0, including 0, and up to 9. And over here, the range, it starts at 0 also and goes up to 3. So the way we read that is the domain of this function is any x value between 0 and including 9. So between and including 0 and 9. And why do we know they're including? Because there's an equal part there and an equal part there. Okay? So same here. So the range are any y values between and including 0 and 3. Okay, that's how you would do that one. Find the domain and range of this function. Okay. And they want between. Okay, so they want the interval notation, inequality notation, we'll call it. Okay. So the inequality notation, x is going to go from 0. So we're going to say domain 0 less than or equal to x less than or equal to 8. And from our range, we're going to say -7 less than or equal to x less than or equal to -3. All right, moving on. Domain and range of the graph here, same idea. So domain and range, interval notation, I believe. Oh no, it's asking us for a choice. So the domain is going to go from, we don't really know, so the pick, well, it's going to be anything here. All real numbers, because these lines up here continue forever to the right, and this curve continues everywhere to the left, so it's going to be any possible x values. Now y, the range. So range, we know we do have a minimum of -2, and then it goes to infinity. So it's going to be x is greater than y is greater than or equal to -2. Okay. There we go. Let's move to the next one here. We got to sketch the graph. So we have these sketching tools. Aren't they nice? Okay. So over here, this is a piecewise function, and so we're gonna have two different graphs put together. For less than 2, we're gonna have -4. So -4 is the y-intercept, so we put a dot down there. And then the slope is 1.5. So 0.5 is 1/2. So it's positive slope up 1 over 2, up 1 over 2. So it's going to look like that. Get that right. So up 1 over 2. There we go. But notice it continues this way as well. But we only want it from here down. So we'll talk about that in a second. So this graph only works for any values that are less than 2. So only from the red dot down. Okay. Now for the other one, we need to have greater than 2. It's going to be -2 is our y-intercept. And we're going, it's 1.5 is up 3 over 2. So we're going up 3 over 2. There we go. And that goes from anything greater than 2. So let's graph this over here. So I think it's better to show, even though the graphing tool is nice and everything, I'm limited to how accurate I can be on this. So I'm going to do it over here. So if I have a graph here, the first one says greater than 2. So this graph only works for less than 2. So it means I'm down 4, put a dot there. That's my y-intercept. And then I'm going up 1 over 2, up 1 over 2. So that's where my graph is going to stop right there. Okay. Now, the other one is for x is greater than 2. So it's 1.5x, which is 3 over 2x minus 2. So I go here and I go up 3, 1, 2, make sure I have the pen on. So I'm going 1, down, so down 2, so it's up 1, 2, 3 over 2. Okay, now that's only going to work for x is greater than 2, so that starts here, and it goes this way like that. Okay. So this line is steeper, this one's flatter, and they have open circles because they're not including. So that's the basic idea what that graph's going to look like, all right? Moving on down. Same idea here. Okay, so let's bring up the tool here. See if I can insert I'll do that later, maybe. Maybe I have a graph, if I can find one real quick. If I can, I'll put it in there. No, okay, it was worth a shot. All right, forget it. Now, go into the graph here. Now, the first one is x is greater than 1. So if x is greater than 1, it's going to be on this side of the line. I have to draw it. Now, just start with the line, then erase the parts you don't need. So greater than 1, it's going to be 2x minus 0.5. So minus 0.5 means it's the y-intercept is down here at negative a half a unit. Then up to over 1. So approximately it looks like that. Open circle, up to over 1. Something of that nature. And now for the other one, which is less than 1, is a positive 3 y-intercept. 1, 2, 3 right here. Okay. Down 3 over 2. It's negative 1.5. So it's negative 1.5 is really negative 3 over 2. So you're going to go down 3. We're in here plus 3. So down 3 over 2. And that's going to be x is less than 1. Okay, so like that. And a little bit over. It's going to look like that approximately. All right, so use those tools and sketch it up. Okay, going down. What do we have here? Oh, we have a three-piece function here. Okay, so if between negative 4 and positive 4, it's going to be a straight line. So if x is between negative 4 and positive 4, y is going to equal 1. So that's going to be right here, right there. That's the middle part there. Should have a hollow dot here. That's going to be a hollow dot at negative 4. Solid dot at 4. Connect that line right there, if I can. Now, what do we have left? Well, we have x is greater than 4, we have plus 6. So we have plus 6, we have a dot there. And negative 1/2, so that's down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. So it looks like something like that. But that graph only works for x is greater than 4, so we're going to put a hollow dot right there. That should be a hollow dot right there, and this should be erased. I'm not erase that, but this graph only works here, so we don't need that part right there. I don't want to play around with the tools, but that's the idea. The other one is x is less than or equal to negative 4, so it's negative 5, y-intercept down here, and then down 3 over 2. So a negative 1.5 is down 3. It's a fraction. Change it to a fraction. Always change the slope, which is negative 1.5 to negative 3 over 2. So we go down 3 and then left 2. All right, now we don't have enough space for the graph here, but we draw the line. Go down this way like that. But remember, this graph is only good for x is less than or equal to negative 4. So actually, this graph is missing the piece that we really need, which I don't know how they expect you to draw it here. But I'll show you over here. So what's that look like? So that tool isn't the best for this. So for negative 4 to 4, you're going to have right here hollow to solid. That's 4 to negative 4. And then greater than 4, it's you're going to have plus 6 up here, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. That's only for x is greater than 4, down 1, left 2. So it's right here, down 1, left 2, down 1, left 2. Okay, so it's going to be a solid dot and of this variety down here like that.